Hello, this is Shivansh Rahangdale. Today I'm gonna explain you the solution of some problems. So the question number one is create a visual representation of the differences between the internet and the web. So we can understand it by having a pictorial representation. So what is internet? Internet is a network of network. And what is web? It is the collection of all the website and pages that are available on the internet. So internet consists of ICMP, FTP, DNS, and all these things comes under internet. And all the browsing cache and all the things related to all the information saved in web pages are in web. That's the basic difference between internet and web. The internet is a global network of interconnected computers and devices that communicate with each other through standard protocols such as TCP/IP. It includes various types of networks such as LAN, WAN, and the World Wide Web. The web is a collection of interconnected documents and resources which are accessed using the HTTP protocol over the internet. It includes various types of content such as text, images, videos, and audio files. What ethical concerns are associated with using the invisible web for data mining and surveillance purposes? The invisible web refers to the vast amount of content on the internet that cannot be accessed through standard search engines. This includes content that is not indexed or publicly available, such as password protected websites, private social media profiles, and unlisted directories. The use of the invisible web for data mining and surveillance purposes raises several ethical concerns, including invention of privacy, unethical data collection, misuse of data, bias and discrimination. These are the things. Uh, Now the other question is how can individuals and organization use two-factor authentication and strong password to enhance the security of their email accounts? It's very simple. Two-factor authentication adds an extra layer of security, and strong password uh, increases the complexity as it includes the combination of high uppercase and lowercase letter number and special characters. So it becomes very difficult for the attacker to perform brute force attacks. Another question is what are the different types of malware and their impact on computer system, and what measures can be taken to prevent malware infection, such as using antivirus software and regularly updating software. So there are different kind of malwares which can be which include viruses, worms, Trojan horses, ransomware, backdoor, rootkit, ransomware, etc. So malware infection can have severe consequences such as data loss, identity theft, and financial loss. To prevent malware infection, individual and organization should use antivirus software, keep software and OS up to date with security patches, and avoid downloading or opening suspicious attachment to links. Now, how can individual and organization train employees to recognize and avoid social engineering techniques such as phishing, pretexting, and baiting, and implement policies and procedures to reduce the risk of unauthorized access to sensitive information? Social engineering techniques such as phishing, pretexting, baiting, these are designed to trick individual into divulging sensitive information or performing unauthorized actions. To reduce the risk of unauthorized access to sensitive information, individual and organization can train employees to recognize social engineering techniques and implement policies and procedures to prevent them. These policies may include how to identify phishing emails, avoiding sharing sensitive or information online, verifying requests for sensitive information before proceeding it. These are the very common measures that should be taken in order to improve the security of the system. The another question is, what are some different methods of securing data, such as encryption, tokenization, and access control, and how can organization evaluate which approach best suits their specific needs? So encryption is nothing but a common method of securing data. Uh, it converts the plain text to ciphertext using an encryption algorithm. And tokenization involves replacing sensitive data with a token that has no meaning or value. Now, the other question is, how can individual and organization use email filters, web filters, and firewalls to identify and block phishing and phishing scams? And what are some best practices for responding to suspected attacks, such as reporting the incident to security team? These are the very common measures that individual or organization should take. So the email filters can set up to block suspicious emails to send them to a spam folder. While web filters can prevent users from accessing known malicious website, firewalls can block unauthorized access to computer system and network. Best practices for responding to suspected attacks including reporting incidents to security teams, reviewing access log, and implementing incident response plans. What are some of the most significant milestones in the history of cryptography, such as the development of the Caesar cipher and the Enigma machine, and how have advances in technology and computing impacted the evolution of cryptographic system over time? Significant milestone in the history of cryptography include the development of the Caesar cipher and then the Enigma machine. After that, the RS algorithm. Advances in technology and computing have impacted the evolution of cryptographic system over time, with modern cryptographic system using complex mathematical algorithm, key exchange protocol. These were all the historic milestones. Now the other question is, what are some key features and limitations of popular cryptographic algorithms such as DES, 3DES, RC4, TOFISH, and AES, and how can organization select the appropriate algorithm for their specific use cases? So cryptographic algorithm such as DS, 3DS, RC4, TOFISH, and AES have different key sizes, block sizes, and encryption modes, which impact their security and performance. Organizations should select the appropriate algorithm for their specific use based on the security requirements, processing power, sensitivity of the data being protected. Factors to consider include the strength of the encryption, the ease of key management, and the potential for attacks such as brute force or side channel attacks. How do public and private key based crypto system works, and what are some practical application of these systems in real world scenarios such as secure messaging and online transaction? So in the system, the public key can be freely distributed while the private key is kept secret. That's the main crux of this algorithm, of this that's the main working of it. When someone wants to send a message to the receiver, they use the receiver's public key to encrypt the message, which can only be decrypted using the receiver's private key. This ensures that only the intended receiver can read the message. Practical applications of these systems include secure messaging, online transaction, and digital signatures. Now, what are some design principles, such as the principle of least privilege and defense in depth, that organizations should follow when developing software and other systems? And how can these principles be effectively implemented using tools such as code analysis and penetration testing? So, the principle of least privilege and defense in depth help organization develop secure system and system secure software and system. The principle of least privilege states that each system component should only have access to the resources it needs to function, while defense in depth means using multiple layers of security controls to protect against attack. These principles can be implemented using tools such as code analysis and penetration testing. Code analysis can help identifying vulnerabilities in code, while penetration testing can simulate attacks to find weakness in the system. Now, how can an organization defend against side channel attacks such as timing attacks and power analysis attack, and what are some standard methods for detecting and mitigating these types of threats, such as using masking techniques and implementing hardware level security measures? So what happens in side channel attack is attacker observe the physical characteristics of the system, such as power, how much power it is consuming, timing function. Organization can defend against these attacks by using masking techniques such as randomizing power consumption or adding noise to the data signal. Makes it harder for the attackers to extract information. Hardware level security measures such as secure boot and firmware signing can also help protect against side channel attacks. Standard methods for detecting and mitigating these types of threats include monitoring power consumption and performing regularly security audits. Now, what are some key strategies for securing Windows systems and implementing effective authentication models such as biometric and multi-factor authentication? This involves implementing several measures. Uh, as we can, we will understand all of them one by one. First one is installing regular security updates. Second one is configuring firewalls. Third, using antivirus software and implementing access controls, using strong password, implementing multi-factor authentication, conducting regular security audits. These were very simple, pretty much simple. Now the fifth question: what standard authentication models are used by organizations such as single sign-on, SSO, and multi-factor authentication? And how can organizations evaluate which approach best suits their specific needs? And how can organizations consider which approach is best suited for their particular needs? So, SSO and MFA uh, are used by organization to enhance the security of their system and data. SSO allows users to access multiple applications with a single set of credentials, while MFA requires users to provide additional forms of identification such as fingerprint or one-time password. Organizations can evaluate which approach is best for their specific needs by considering factors such as the level of security required, the number of users who will need to authenticate, and the cost and complexity of implementation. They can also consider the risk of different types of attacks such as phishing and credential stuffing and choose an authentication model that can mitigate the risk. Uh, Now the question: what is trusted computing and how does it differ from traditional security models? How can organizations leverage trusted computing technologies such as hardware-based security models and remote attestation to enhance the security and integrity of their system and data? Trusted computing. What is trusted computing? It is a security model that focuses on the integrity of the hardware and software components of a system. It differs from the traditional security models that rely on software-based solutions such as firewalls and antivirus software. Organizations can leverage trusted computing technologies such as hardware-based security modules and remote attestation to enhance the security and integrity of their system and data. Hardware-based security modules provide a secure environment for sensitive data and operations, while remote attestation allows organization to verify the integrity of subsystems, hardware, and software components before allowing access. Now the last question is explain how the virus works. Explain any 10 viruses. So what is a computer virus? It is a very common term that everyone uh, knows. A computer virus is a type of malware that spreads by infecting executable files or documents. Once a virus infects a system, it can perform various malicious actions, such as stealing personal data or damaging files. Here are 10 examples of virus. The first one is I love you virus, a virus that spreads via email in 2000, causing damage to millions of computers. Another one is WannaCry. It is a ransomware virus that affected hundreds of thousands of computers in 2017. Third one is Melissa virus, that spread via email in 1999 and caused millions of dollars in damages. Code Red, a worm that infected servers running Microsoft IIS in 2001, causing widespread outages. MyDoom, it is a worm that spread via email in 2004, creating a backdoor that allowed attacker to control infected system. Zeus, a Trojan that stole banking credential and other sensitive information from injected system. Configure, a worm that exploited a vulnerability in Windows system and created a botnet with millions of infected computers. Stuxnet, a worm that targeted industrial control system causing physical damage to centrifuges used in Iran's nuclear program. CryptoLocker, a ransomware virus that encrypted users' files and demanded payment in exchange for the decryption key. Mirai, a botnet composed of infected Internet of Things devices (IoT devices) that was used in a massive distributed denial of service attack in 2016. So we have understood the what is virus and the working of virus, and we have seen 10 types of viruses and of a little bit about their description. So that's it for the video. Thank you.